Hello, my name is Sir Isaac Newton, and welcome back to my channel. I have previously talked in my past videos about my greatest accomplishments in the world of science and physics. And in those conversations, I briefly talked about my contributions to mathematics. I've done a lot for math. I even created a whole new subject of math called calculus. In this video, I will partially explain my contributions to calculus and math, and hopefully I will give you a brief understanding to the math that I, Sir Isaac Newton, created. Calculus, the branch of mathematics that deals with the finding and properties of derivatives and the integrals of functions. Now, what does all that mumbo-jumbo mean in the first place? First, a derivative is a function that gives the instantaneous rate of change at any point on a curve. An integral is a function that its given function is a derivative. So today I'm going to be teaching you a little bit about derivatives and integrals and a little other thing that I created that's more algebra, and that is called binomial expansion using the binomial theorem. The binomial theorem basically states, and most of you guys might already know how to expand a binomial, and all I'm saying is basically a binomial saying that this is your normal binomial right here, the a plus b. Now that is a binomial. You guys have probably already seen a binomial. Now, this right here is obviously a power, and you guys have probably seen a binomial say an x plus 3 squared. That's all this is. It's just this, but it's just if there's a bigger exponent, a larger value as the exponent. So the expression I'm going to be using today is going to be x plus 2 to the power of 5. That you could just multiply it out, you know, whatever is your choice. You could multiply that out, x plus 2 times x plus 2 times x plus 2 times x plus 2 times x plus 2. But we're going to find an easier way to do that, quicker. It's up to you though. So what we're going to do first is we're actually going to take x and we're going to put that to the power 5, and we're going to go downwards, almost like in a descending order, but we're going to lower the exponent by 1 every single time. I'm not going to show you the formula in general because it's honestly kind of confusing, and I'm just going to kind of show you how to do it. You should have 6 different terms there, and then what you're going to do is you're going to do your b, and you're going to do that in ascending order right in front of this. So it's going to be 2 to the 0, and so on. Like, it's going to go 2 to the 0, 2 to the 1, 2 to the 2. I'm just going to do this right now. So as you can see here, we have all these right here. And actually there's addition signs in here getting multiplied together. So x to the 5th times 2 to the 0. We're also going to have the combination of 5, which is our exponent right here. So as you can see, now we have all these. I had to kind of squeeze them in, but we have 5 choose 0, 5 choose 1, 5 choose 2, and so on. So now we just solve it, and that is it. After you solve it, it is very simple. So 5 choose 0, there's one way you can have that. So that's 1, and then we have x to the 5th. Just bring that right down. And then 2 to the 0, 2 to the 0, anything to the power of 0 is 1. So we'll just leave that like that. So that right there is actually your answer. That right there is what x plus 2 to the power of 5 is equal to. And as you can see, I mean, it's up to you. It's up to you if you would rather multiply all these out, or you can do it this way. You can easily do it. And after you probably get the hang of it, it will be very fast. You can probably do it so fast because these 5-pick ones or whatever, they're so easy after you memorize them. Alright, now let's erase this and... Now, as I explained calculus to you, for the sake of the ones here that have a brain that's not able to comprehend other than their own desires, here's a cute cat video while I explain derivatives. Alright, so time to explain derivatives. So this might actually look a little confusing, or it could look very familiar. So Pretty sure all of you who's watching this video have seen a graph like this, x and y graph, normal x and y graph. And most of you, if you're in algebra or even in pre-algebra, or you might already know about it. This is parabola right here, as you can see right here. That's a parabola. It's kind of like half, it's cut off because it goes into this other part, it goes into the second quadrant. But we're only going to worry about this part. So as I said, a derivative is a function that can tell you the rate of change at any point. So we're going to say this distance, so we're looking at these 2 points for one. These are 2 points that we're going to be looking at, and we're going to find the rate of change there. So the distance between these points, we don't know. We do not know the distance between these points, so we're going to call that h. So this coordinate right here is x, f of x. So x plus h as our x coordinate over here at this point. And then our y coordinate is the function of x plus h. And it is y2 minus y1 over x2 minus x1. So you can already see that we can simplify this already. We have two x's, a positive and negative, so we can go ahead and simplify them, just take them away. This is actually halfway through already. This is called your difference quotient right here. This is what you're going to use to find the derivative. Now I'm going to use an example for an equation, 3x squared plus 12. And we're going to use that, and we're going to find the derivative of that into this graph. After you plug all those numbers into that difference quotient, you'll get this. Now, I'm going to save you the pain, and I'm going to simplify that right now, and I'm just going to put it down, the simplified version. And this actually comes out clean, because when you simplify that down all the way, believe it or not, it comes out to be 6x. This, right here, 6x, that is your derivative. So now, hopefully, I feel like I've taught you a good bit about this subject, and now that I've taught you derivatives, it should be...
Hello, what are you doing?
Get out.
No. Hello. Hello.
Get out.
No.
Now, I'm just going to explain integrating very simply to you, because honestly, it's so simple. So we're going to use this thing called the power rule, and it's x to the power of n plus 1 over n plus 1, and we're going to integrate this formula, we're going to integrate this equation right here, this expression. So we're going to use each one of these terms and put into this formula. So x to the third, x to the 3 plus 1, so it's x to the fourth, and then you do the n plus 1 over 4. See how that's x plus 4? X to the fourth over 4, and you basically do that for every one of these terms until you come out with this, and then you add this plus c on the end. We're not going that deep into calculus, so you won't know why that plus c is there, but it's there just because. And then you can also simplify all this down a little bit more. And honestly, that's it. That's how you integrate. I hope you guys learned something in this video, and I hope you enjoyed watching the funny cat video and everything like that. So, thank you guys for watching, and I am Isaac Newton. Thank you for watching. Bye.